And welcome back to your regularly scheduled programming. I am John, the Code Man, and today we are going to continue working on our copy shop. So, the last time we discussed putting together the different methods that we've learned throughout the course so far and creating something kind of neat with it. We talked about how we can use the variables. Let me zoom out just a little bit. Pseudocode, yes, that's a good thing to review. So, what this is an outline of kind of what we want the code to do. We've described that we want it to display the name of the shop in English, right? We don't have to write the code for this just yet. We want to show a menu of options and we want to give them a certain values, one new sale, two current sales, yada yada. And then we have our conditional logic. So depending on what button the user pushes, we're going to do different things. If the new sale, then we want to give more options for coffee or cookies. What do you want? If the coffee is selected, then we got to pick what size. So what we're doing is we're emulating a point of sale system that one would find in a coffee shop. Now we're not going to put any graphics or anything on it. We're just going to keep it all text-based, printing to the screen as it were. So I'm just going to show mine. Not quite. I'm going to move this off the screen because I don't want to show you the whole code yet. I just want to execute it. It'd be good if I uncommented the code that I want it to run. Comments are great. Make sure you uncomment when you're ready for them. Do, 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 do. This was a project that I did when I was at university, my 101 class. Shout out to Dr. Tom Rischel if you're watching, you're the man. Love that guy. Crazy smart. And uncomment. I'm going to run it. And I'm going to show you what the run looks like. All right. I'm going to zoom in. And our employee name. I'm just going to skip the fluff and just show you. I entered John. It recognized that John was a valid username. And it prints out the menu. This is the standard menu. Although I have a bug here, incorrect menu choice, which is weird because I didn't actually enter in a menu choice. So there's a flaw in my logic I have to look at. But I have this printed to the screen, and now it's expecting a selection. See your cursor. This is in what's called a while loop. Your computer runs on a while loop. While you haven't selected the shutdown button, it will continue to run unless it crashes. Oh, 90s. It's a rough era. All right, so I'm going to hit the number 1 for new orders. May I take your order? Enter the customer's name. John the man. Enter number of small coffees. So I think the way I set it up was I allowed for a person to have multiple different iterations. So if I want no small coffees and I want 2 medium coffees and 2 large coffees because I'm bringing some to church or whatever, and never mind about the cafe. All right. So the total sales is 7.8. It's supposed to be $7.80. It's actually doing something called truncation, where it's going to ignore that last zero and it's not being displayed here. It's kind of neat because there is a way around it to, I guess in science, there's a thing called sig figs or significant figures. We can tell it to pay attention to 2 decimal points or 2 spaces after the decimal point, which is how we'll get our actual round numbers, which is nice. Otherwise, it's going to truncate it if it's a 0. Now, if it was a 5, it would have left it, but it was a 0, so. And then I have the program reprint out the menu for the next sale. And then let's say, I don't think I actually have cookies in here. So now I have the number 2 goes to total cups sold. I want to remind everybody that I did this in, what year was that? 2017? I haven't touched this code since. It has been a while. So we've got some improvement to make. But I have 4 small. I also did this in a different programming language. This was in C++. Um, so I have a total 2 small, I'm sorry, 0 small, 2 medium, 2 large, and then John Shop. Can make another sale. This time we're going to go Andrew. And let's say he is getting one small coffee, no medium or no large. So then his sales total is $1.75. Inflation's really hit us hard. If a small coffee is only $1.75 back in 2017, now it's like $4. So anyhow, so now that's adjusted our total sales and our total cups of coffee sold. So I'm going to hit the number 2 again. And now we have one small, another bug. It didn't collect the total between each one. It only did the most recent iteration. So there's a problem with memory. This is kind of fun for me. Let me show you how many different ways to break it. And that's the best thing about coding. Well, one of them. I'm going to say that 500 times. Is when you write something, try to break it. Do some quality control on it, because when breaking it, you're going to learn so much. The old adage is you learn more from failure than you do from success. Fail a lot. It's going to be great, and you're going to learn so much. I was at work today, and I was trying to figure out how to take a Google Sheets. It's like an Excel spreadsheet, and I have a list of about 82 rows of information. Thank you. We're having issues with the stand again. Yeah, I dropped it earlier. All right. Keep the hands on. Okay. So I had a row of about 82 different rows of information. This has nothing to do with this particular lesson, but it's good fun anyways. So I wanted to make each row in triplicate, but I wanted to do 2 spaces between each one. But I didn't want to go through each line and right click and insert 2 and right click and insert 2. And I was like, there's got to be a way to do it programmatically. And there was. And I probably may have spent more time figuring out how to do it with the program than actually clicking. But then I was able to edit that program and do some copying and change some things as I was filling everything in like it needed to be. So that was it was a neat experience. That leads me to this. If you're doing something in programming and you're thinking to yourself, man, there's got to be an easier way to do this. Odds are there is. You just got to go find it. You can use your different resources. We have things like ChatGPT nowadays, but you can use a website called Stack Overflow, or just Google whatever the error is, put it into Google, and boom. Odds are somebody else has had the same problem, and you're able to figure it out. Which is exactly what I did, because I had a variable issue. Turns out it was my fault. I wasn't putting the right parentheses where it was supposed to go, so that's why it took extra long. So break stuff. That's the moral of the story. Break it. Now we're going to go to total sales. Now, if we remember, the first cup of coffee, the small cup of coffee was $1.75. So if this shows $1.75, I love how I have to keep scrolling up, then it's not remembering the first customer's order at AM. Our sales are going to be off completely. Our inventory count's going to be wrong because we're not remembering. And then we can click 5 to exit. Again, this is all in a big while loop. Have a great day. See you tomorrow. How cheesy, right? So we're going to look at the actual code now. This is something Dr. Rischel used to do too. Shout out Dr. Rischel, you're the man. He would execute. He would always give us a choice. He said, "Do you want to see the code first, or do you want to? Oh yeah. Or do you want me to run it first and then explain it?" I'm actually showing you things right now we haven't actually covered in class. Actually. How many times can I say blah blah? So I put my code into these things called functions. Let's see if I can remember the shortcut. That's not the button. Nope. Giving up. These functions are like little boxes that can be used to split up long, arduous code into individual sections. And it's really neat because you're able to click this little side arrow and it collapses everything into it so that you don't have to have everything on one line. Up until this point, you haven't even seen everything unless it's on one solid row all the way down. What this does is it compartmentalizes. Modulates, that's the better word. It modulates the different sections. And then here is the main function where it actually calls them. So we're going to go through the main. We'll cross each of the individual functions as we get to it. But the way that you make one is you have a def, def, that's one of those special blue keywords. It stands for define, right? The name of the function, notice how whenever I put this, I hover over it, it tells me that it's a function. Just like with our prints from earlier, prints is a function. It prints whatever's on the inside. That's what this is saying here. But it's a function that's already built into Python. We have our own custom functions. We just happen to call this main. It's our main function. And then we call the main function later and does everything inside of it. So I have my variables here. I have num small, num medium, num large, these are numbers, and then a menu choice. And then I synchronize them all to 0. Initialize is a better word there. I could have just as easily done num small. You could really tell this was a long time ago. I'm not even using camel case is equal to 0. And then num medium. See, now I'm trying to get back into that habit. Equal to 0. But whenever you're doing many things at a time, you can initialize them all at the same time. So we have num small is correlating to this first item. Notice how they're separated with commas. Second one, second comma, third, and so on. These don't all have to be zeros. They can be, different things. Doesn't necessarily have to be integers. I just happen to be using integers because that's what the program calls for. I'm doing the same thing here for ounces total and sales total. That's supposed to be keeping track of how many ounces of coffee and sales in dollars that we're actually making for the day. And then I have our first function. Well, I guess technically our second one if you're counting main. I have an if statement here. As a reminder, if test conditional logic, not is a keyword. So if not verify employee, menu choice equals 5. What this is looking for is a true value. So if not true, verify employee is either going to return true or false. Notice how when I hover over it, it tells us that it's a bool. That's another data type. Bool is a true or false. All computers run on electricity. Surprise. Using electricity, it's made 1 and 0s. You might have heard binary code before. Ones and zeros. We're all 1s and 0s, man. Sound like a techie hipster. Is that a thing? I don't know. It is now. You're welcome, internet. So if not true, so it's looking for false. So if employee returns false, the menu choice is equal to 5. And we saw from our example that menu choice being 5 closes it down. It exits the program. Right? So it's looking for if not true. With this if statement, if this returns true, then it's going to do what's on the inside of it. If it doesn't return true, then it's going to continue on. Let's look at what verify employee does before I confuse myself. Wonderful comments. Comment your code. Please do it. You'll thank yourself 6 years from now. Takes input for the username and checks it against the proper list. So we have our def, our verify employee, open and close parentheses, and then a semicolon. I'm sorry, a colon. These are the things, the recipe, if you will, the syntax for developing a new function, user-created function. We have our define, and then we cap it off with a semicolon, and then the name of it, along with these parentheses here. If we got rid of any of these elements, the computer would know what's going on. Like, what are you trying to say right here? I don't understand. So the first thing we do is we print the startup screen. I don't remember doing that. I might have forgotten. And then I have a counter. Why do we have a counter? Because we have a while loop here. While the value of counter is less than 5, it's going to do the stuff inside these parentheses. I'm sorry, inside this indentation. With Python, This white space normally doesn't matter, but only in the case of these conditional logics and functions. So everything on the inside of this while loop, notice we have this little drop down arrow, collapses back up. It's not going to do anything inside if that condition returns false. Just like everything that's inside this verify employee function won't execute unless it's inside, unless this was called. Forgot to mention that. So whenever we print out or type out a function like we have here, that's called a call. So we're calling that function. That means we expect a response. We're expecting either it to return true, you're an actual employee, or false, you're not an employee. So it's called a call. We're calling that function.
Can you open it back up?
Yeah, I will. I just wanted to come back down here too real quick. If you hit control, this internet video is going to be bonkers. I'm using a music stand and it's anyhow. So if you are in your code and you want to go quickly to the function instead of scrolling all the way back up, you can hold down the control button on your keyboard and then use your mouse or touchpad to double click on it and it'll take you to where it's instantiated or created in your code. So we created all these things ahead of time. So back to, what does this do? Yes?
Sorry, I'm very curious about something else. The return true, is that telling verify employee to return true? What is returning is true?
Are you talking about 66, 7, and 8?
69 specifically.
Okay. We'll get there in just a second. I like your enthusiasm. But we have our counter. Why do we have a counter? Because as long as that counter value is less than 5, we're going to give them another chance to enter in the name. Right? You get 5 tries. So then we take an input using the blue key. I just bit my tongue. Going too quickly. So using this blue input keyword, we put inside those parentheses what we want to print out to the screen. It's a prompt. We're printing that out to the screen. We're getting an input from the user. That's why I typed in my name earlier, John. So they save that variable, we save that variable to names. Now before the lesson, we talked a little bit about white space. We put some white space here at the end of the query so that whenever the user types in their name, it's not right next to it. There's a little bit of space that makes it a little easier to read. So we got our first name. Then we check. We got to check if the name is equal to Jason. Apparently, Jason was the previous Andrew. So we're going to check if the name is either Jason or the name is John. I don't know why I put plural, but okay. And then there's a semicolon. You can also surround this with parentheses. This may be a C++ habit, but it kind of groups the logic together. It makes it easier to visualize. So if either this first thing is true or the second thing is true, do the stuff inside the indentation. So in a previous lesson, I talked about if I'm hungry or if I'm thirsty, I'm going to get food or drink. So if one of those two things were true, if I'm hungry and thirsty, I'm still going to go get a drink. If I'm only hungry, does that make sense? That's the or logic. If we want hungry and thirsty, if this was an and, if the name was equal to Jason and the name was equal to John, we'd have an error because the variable can only mean one thing. So, or. So we know that the input was John. It checks against the string John, the keyword, if you will. And then it prints access granted. Welcome to work. And then returns true. Again, we called the function. The response is true. So what this is going to do is it's going to return true back to where we called it. So this is going to print out, I say print out, it's going to look like it says if not true. But it is true. So it's going to skip the rest. It's not going to do 139. Oops. Okay. And it's going to continue on to 141. The menu choice we established was the number 0. So the checks the value of menu choice, it's not 5, which is the exit number, and then it calls another function called display menu. But what happens if they get the spelling wrong? So if the name wasn't Jason or John, we're going to print out, do you even work here? I'm just going to do it for funsies. We're going to say Nate, Andrew, Joseph, Steve. It's my over the head reference. Now this is 4 attempts. Nate, Andrew, Joseph, Steve. So our counter is right about to be 5. And our conditional logic has it to where as long as it's less than 5, not less than or equal to 5. That's important. The second most common error in computer science, period, is called an off by 1 error, where you think you're close. Like if we would have had an equal sign here, we're expecting to have 5 attempts, but really you'll end up with 6 because that counter starts at 0 and it goes all the way up. So that's why if you have trouble, that might be one of the things to look at. Second most common computer science question. So let's go Ashley. And then I print out intruder alert 1,000 times. It does it very quickly. On a slower computer, it's more impressive. That was quick. Intruder alert. This is kind of fun. So while the counter is less than 5, so if the counter is greater than 5, it breaks out of this while loop and it does the next thing. Else is similar to, what did we say? Otherwise. So while counter is less than 5, do this stuff. Otherwise, do the rest. If the name is equal to that or that, do the thing. Otherwise, print out to even work here. So else is another word that we can use for otherwise, but else is the key word, if you will. We have a condition for elif, which is else if, and you want to check a second condition. So I could break this up. We'll just copy it as my computer is sliding again. I can imagine what this is going to look like online after. So everything's still in line. I'm so thankful for these little dots. So if I want to check a second condition, so we'll check James first. Notice that I just deleted that white space here. The computer doesn't care. I like it because it's prettier to remove it and keep things nice and clean. There's a certain standard that people try and go with. PEP 8 is what it's called. If you're curious later, if you want to look it up on Google, open a separate tab. But it's the coding convention. It's the standardization, if you will. It's not heavily enforced. No one's going to take it, I don't know, coding jail, make you do an infinite loop. Man, that joke was so funny. So if this is true, do 68 and 69. Elif, which is the same in other languages as else if. So we have a second condition that we want to check if this first one's not true. If it is true, it's going to go all the way down and it's going to ignore the rest. It's going to check 67 first, and then it's going to check 70. And if it gets to 73, then you know that it's not, that the first 2 conditions have failed, right? So if this is true, else if the other thing is true, otherwise we have a default here. We don't have to have one there. I just like to have all the bases covered. That's Midoriya on my shirt, in case any of my internet people want to know. Huge nerd. But I like to have this together as an or, because it does the same thing effectively. Or does it? This doesn't tell us which name is logged in. It just makes sure that the person is verified. It doesn't tell us Jason or John. If we wanted to, we could do something else depending on which one is the case. That's not necessary for now. Okay, you even work here. And then for I in range 1,000, print intruder alert, and then it returns false. So if it gets to this else statement, that means that while has failed. Or I guess not really failed. The while is expired. Yeah, broke out of the while. So then it prints the alert, and then it returns false. If you put return anywhere in a function, it's going to not do everything afterwards. So for example, notice how we have the return here. It means if we ever got to 69, even if the counter is still good, even if it's still less than 5, if we hit the return, that's what it's looking for. That's the response, right? We called it earlier. Now we have the response. Is that on? Hello? Oh man, that's from my Cutco days. Got to call the customer to set an appointment. I used to sell knives. Um, it was a lot of fun. Cut your deal. I'm all over the place tonight. So there's a response. If it sees the response, that return keyword, I love that it's all highlighted in blue. It's a pretty blue. That one's for Gabriel. Returning false. So then it goes down. And what happens if it returns false? There we go. Then it's going to say if not false. Not false is the same thing as true. And we know that if true, it's going to do what's on the inside here. So we verified, and then that subtlety of the conditional logic can slip you up. I know it's done me so many times. Where it's like, all right, if not employee, what does that mean? So this is looking for a true or false. This is going to return one or the other, but not flips it on its head. It's like if my wife tells me that she's not hungry, she's hungry, right? You got to flip it. I'm going to get in trouble for that if she watches this later. Love you, honey. She won't. She won't watch this. It's too long. What are we, 35 minutes in? Kudos to you guys for sticking around. Thank you so much for joining the YouTube video. Like and comment. Make sure you subscribe. We've got 80 something videos on our first, or views on our first video. So thank you all, whoever's watching this. This is for you. The editing is terrible. So if not false, means if true, it will do what's on the inside. And I say the inside because in C++ we used to have these curly braces, kind of like that, where we had to specify what would happen, and it wasn't white space dependent, so it didn't matter how many spaces we had. As long as it was within the curly braces, I could theoretically put all this on one line next to the actual function name, and it would work because it's not looking for the white space, where Python is white space dependent, and honestly, it makes it cleaner, in my opinion. And I also notice how I like to have some spacing between. The extra spaces are free. Go ahead, Nise. It's a good question, for sure. The spaces here matter how many spaces you are from the wall. So if I put that space here, it starts to yell at you again. Even though it's almost indistinguishable to the naked eye, unless you're like really close to this TV like I am. Look at that. Really close. Inception. Okay. It's going to give us the error eventually. Unexpected indentation. Tradition has it that it's 4 spaces. You can also do 1 tab over. That was cool on the video. Sorry. Man, I'm on it. So if not true, then we'll open another while loop, and then we check to make sure that that many choice is not 5. That's our condition. As long as, which is another way to describe a while loop, as long as this condition is not true. I'm sorry, as long as this condition is still true, that's a better way to say it. Do the stuff on the inside. If it's ever false, breaks out. Just like we did with our 5 chances with our first while loop that we saw. As long as that many choice is not 5, that's this exclamation point means not. So I like to use it here. Not equals. If we are here, then many choice is 5. We have an intruder. We don't even go into the inside of this while loop here. It breaks out before it even gets started. We got people. Hello, people. I got to figure out how to work the air conditioning. So we make sure that the choice isn't 5, and it's not 5. Not yet, anyhow. Right. So we made sure that the menu choice wasn't 5, because if it was 5, that would mean we have an intruder. And we display the menu. That's the next function that we're calling.
As a side note for you guys, if you're going to make a menu like this, sorry to interrupt, just sharing a lesson that I learned hard way. It's better to show. Yeah, there you go. It's better to have it set up
That
different,
really bad.
somewhere else. Like this is menu, print menu, kind of thing. And like, so my issue with the code is I didn't.
This looks like a lot. But what it does is it's a bunch of print statements. Where's my mouse? Spaces. No. Let's see. I'm going to put a breakpoint here at the display menu. So it's going to run the code up until line 80, which is kind of tricky because it actually skips 80 first and it goes to the main. I'm going to type in John for the employee name so we can not have the intruder alert screen. Now I'm going to retype it because I misspelled it. So now we're here. So it printed 50 spaces. First it was 2 new lines. There's the new 2 new lines. And then it printed out 50 spaces. Oops. Yeah. And then it started with John Shop. Dot format John Shop. \n. That's neat. So then it's going to print that again and do main menu. I'm going to go over here to the next step. So this \n is a new line character or carriage return on an old typewriter, right? So we still keep that in order to tell the computer, go to the next line. And then we have 50 blank spaces, again, as a format. And then we have the main menu printed to the screen with another new line.
I'm sorry, the print with the double N, that's why it skipped 2 lines before it did the 50 spaces.
That's correct. This is 2 \n. Those are special conditions inside of a string that tells the computer to do something unique. If I didn't want it to do that, there are other things I would have to let it know that I actually wanted a \n literally instead of a new line. There is a \t for a tab. There's another one I can't remember. Moving on.
Question.
Yes.
The commas.
Oops. Oh, I broke out of it. Let me go ahead and stop the code. The commas what?
The commas in between the \n's and the 50 spaces thing.
Ah, yes.
Are those important, or are those just helping you keep track of the code?
It's a certain condition formatting. This dot format, right? It takes in certain arguments. It's a method or a function in itself, just like we did with print, with our parentheses. Dot format has parentheses, and it takes in conditions inside that parentheses. The formatting is going to be applied to the string John Shop. But what formatting specifically? That's what comes beforehand in these conditions here. So first it's going to print those 2 lines, and then it's going to format on the next line 50 characters, takes in that argument, that literal, and then it takes in a literal string, which is funny because literal doesn't mean literal anymore. And then it does another new line at the end. So it is, in essence, three separate print statements collected into one. Prints out the first two new lines. Then it prints out a formatted version of John's shop. In this case, we put 50 spaces to the left of John's shop prior, and then one new line after. If I wanted to make this 100, make the menu bigger, I could do so. It's better than doing just a bunch of blank spaces. Um, it's a little extra, but it's kind of neat.
And the star, you're basically saying
To print the star 50 times. This is a mathematical symbol, the star key. It's a multiplication. It's another way you could have done it. Real extra. I don't know what I was thinking.
no, it's awesome.
But I like the square brackets here for the menu. And then notice I've got two tabs here at the end, I guess for the spacing. So it prints the menu. And then I also put some notes. Again, comment your code. You'll thank yourself later. Opens a new order screen, point of sale system. Maybe not in that order. Shows cumulative total cups sold for the day. That might be how you spell that word. Displays total ounces for the day. Now we know that there's something wrong in that. We're not going to have time to fix all of it. But I would like to at least try to fix the cumulative total of new orders. Actually, it might be better to do it in ounces. We'll see. We might get to it tonight. Any questions on the display menu print statement?
The square brackets with the numbers in each one.
Yes.
The square brackets so that way if somebody used that function, it would automatically know what to do.
That's a good question. This is really just for the user interface. If we're looking at this on the screen, it just, instead of having a 1 by itself, it looks like an actual button. We don't have buttons in a text-based program like this, but it makes it a little more clear on what you are expecting from the end user. Unfortunately, people break stuff all the time. You kind of have to verify, and we talked a little bit about this at a separate lesson. Verifying user input's really important. So if I have these listed here like this, it's a little bit more intuitive. Okay, 1, new orders, 2, and then at the end it is expecting a choice. So I have a make a selection, right? And then it prints out what the selections are, and then I can hit the key. Does that make sense? It doesn't have to have the square brackets. Again, this is still just a print statement like we did before the class with just John. This is just a little bit of formatting to make it easier for the user.
I think one that you can tell is the coloration of the two. That helps a lot. So if it's colored in that, what is that, pinkish, tannish, whatever.
Yeah, that's what we'll go with, orange almost.
Orange,
What do you guys think?
It'll just be text that's printed on the screen. But if it's blue or white, then it's probably going to be
something else.
Doing something.
This is very similar to like an F string, now that I think about it. The formatting. Neat.
This is another thing I was going to ask. Format or just F?
I don't know. I'll get back to you. I'm not sure. Actually, this is what my teacher used to do all the time. Go home and try both and see what different results you can get. That's one of the best things about programming is you get to break stuff. Go and see what happens. It's not the best way to actually do analytics work. Trial by fire. Moving right along. We've got about 10 minutes left. So we have our choices. We print the menu. And then we have a new choice is being equal to, now this is a variable that we had set up as 0 from the beginning. We got in the new choice, but we're taking it in, again, this was just the menu printing. We didn't actually have an input statement in that section. And this is another important lesson. When you make a function, you want it to do one thing really well, and that's it. If you've got a function doing a whole bunch of different things, it can get a little confusing, convoluted, clunky, congested. Insert 4 other C words here. It's terrible. So instead, we just had one function to display the menu. And we know that it displays the menu because that's the name of the function. That's called self-documenting code. I don't have to have a note next to it that says this will display the menu because it's in the name. Do things like that. It will make your life a little easier. And then I'm just curious as to where else we'll have this display menu. Do we see other places? No, because it's in a loop. It prints that menu right at the beginning. So we don't have to have it 500 times. But we do need to verify the menu choice. Question?
Question, sorry. So with display menu there, you don't have to have print in front of it? You don't have to have like a weird format?
It's a good question. Display menu is actually a function. We're calling the function. It goes all the way back. Ooh, I don't know what I did. Here we go. It goes all the way back, and then it does everything on the inside, which happens to be a bunch of print statements. So it prints the menu.
Gotcha. So it's just cool.
If we did print display menu, it would print like a weird long negative number of what the computer thinks that memory address is for that function. You can definitely break it. But we put the print statements here because it is kind of clunky, and it's best to keep it, in its nice little capsule. And then Bulma calls it later, and then it prints out the menu. Okay. So now we have another function, verify menu choice. I hit Control, click on it, verifies the selection. If an invalid one is given, it prompts the user to re-enter it again. Wow, my English is terrible on this. Menu choice is equal to 7. I have a default value for menu choice that's 7, which is a weird number, but we'll find out why in a second. This is kind of neat. I like whenever you highlight it or click on it, it shows you where all the things are being used. That's neat. So we have another while loop. So while the menu choice is not in range 1 through 6, that means if it's not 1 or 2 or 3 or 4 or 5 or 6, I'm sorry, or 5, because it's a start and stop value. If it was just one number, if it was just 6, it would include the 0. Because computer science normally starts at 0, counts at 0, as the first iteration. I saw some things online that says, am I number 1 in your life? Absolutely. My code is number 0. Lame. But it defaults, the range defaults to 0. So notice here it has range stop. That's where you're telling it to stop. Defaults to 0. If you have 2 values, it's a start and a stop somewhere. Yeah. Step is defaulted to 1. That's if you're wanting to count by 1. If I had 1, 6, 2, then it, not 12, good grief. Then it would only do it 3 times because it would do 1, 3, 5. It's steps. Those are the bigger steps. Like if you try and go up a set of stairs or a flight of stairs 2 at a time, don't do that. It's bad for your legs. I don't care how fit you are. That's the steps that it's taking to get to the end. So start, stop, and step. We just had start and stop. Here, I think that's where we were. Yeah, good. A little bit of space. So if it's not in the range of 1 to 6, which is really 1 through 5, which if you remember what our menu looked like, those are our options. So if they give us something that's not in that range, we're going to print out incorrect choice entered, new line. Please re-enter your selection. Notice how there's not a space here, because I don't need a space. It's on a new line by itself anyhow. It's going to be in line. Please enter your selection. But there is a space here, because when they enter their selection, that's where it's going to be. So new choice is equal to integer input, parentheses. It converts their input to an integer so that it can make that comparison of 1 through 5. That may not be the best design, because if they enter in the letter X, it's going to break it. So we'll have to redesign that conditional logic, but for time's sake, we're going to leave it. So it's going to return the menu choice. I say it's going to return the menu choice. There we go. So we called the function. It returns back whatever we gave it that satisfied that while loop. That while loop was looking for anything from 1 to 5. So whatever it is, if we got to 145, it was happy with it. So then it checks the values. If the menu choice is equal to 1, do the sell coffee, and that returns 3 different things. I know, you can return more than one value. That's bonkers. We'll have to wait until next time for that. If the menu choice elif, or else if, the menu choice is equal to 2, then we're going to print the number of cups that are sold, and then we're going to grab the variables that are saved in num, small, medium, and large. Just prints out those values to the screen. I'm sorry. It is a print cup. This is a little tricky. That is a print cup sold function. Just to look at that real quick, it passes in the values of those 3 and then prints them this way. It's another print statement disguised as a function. But this actually does total cups sold. Interesting. And then number 3, if the choice is 3, prints the ounces as a function. And then 4, show me the money, which is a funny function for however much dollars have been sold. Using this methodology, you're able to take a very large program and modulate it into smaller chunks. One of the biggest, most important things of computer science is to be able to take a problem that seems larger and to break it up into tiny bites so that you can zoom in, fix what happens whenever they pick number 1. Okay, then we're done with that. Zoom back out. What if it's a 2? You zoom into that one. You can go back out. And by using functions, you are able to modulate that easier. I could very well have just put all of this all in one, but it would have been ginormous. I've seen yours. It's huge. But if you were to use functions, which is going to be the homework, you're going to take those concepts and break them into these individual function calls and responses to clean up your code and make it more modular. And with that is our time. I want to thank you again for coming to your regularly scheduled programming.